Very good morning, students. Welcome to prestigious IIT and NEET Foundation, or Focus C program.
Good morning, sir.
By Krishnaveri Talent Schools and the Mastermind Schools. So once again, I welcome all the class 7th students for today's session. As you all can see on the screen, and you are well aware, my subject is physics. We are in class 7th. Our ongoing chapter, the second chapter, motion. And today we are entering to the session number 4. So far we completed 3 classes in knowing about the basic concept of motion and rest, followed by few important terms which you come across during the motion. Then the relation between that motion called equations of motion, right? Under the synopsis 1 and synopsis 2. So today, before going for the next topic, we'll recall what we learned so far and we'll solve some levels, that is worksheets related to these two synopses. The first one is motion and time and terms related to motion and time. The second one is about equations of motion, which we discussed in the last class. 3 equations. Right? One more is there, we'll discuss today. First, we recall all of them, and then we go for the worksheet related to these 2 synopses, level 1 and level 2, as per the availability of time. Remaining, you need to practice from your end. Right? So, before that, so as you already given information for you, we are going to have the second test, that is test number 2. One already we completed last month as the 26th August is the last Monday of the month. So our scheduled time is on 26th, but due to holiday on 26th, you can conduct the exam later, either 27th or some other day, as per the receiving of question papers, which are already dispatched from the printer, right? So make sure that students is prepared well for the exam and wrote the good exam compared to the last test, right? So I'll move forward for the review, what we learned in earlier sessions. So we started with the what is rest, what is motion, the 2 important terms. Because whenever there is a motion there, rest is also comes, because both are relative terms. Both are relative terms. So we discussed, we can see clearly, the body moves, changes its position with respect to surroundings and time. It is called bodies in motion, like flying bird, a boy playing a football, right? But if a body is not changing, does not change its position with respect to surroundings and time, it is called as at rest. See, book lying on the table, a bench fixed in a park, they comes under the rest. So both are very important in physics. Rest is studied under the branch called kinetics. Motion is studied under the heading called kinematics, statics and kinematics, which are the parts of mechanics. Then when your body is in motion, suppose when a body started moving, every moving body will cover some distance, and based on its direction, it is termed as displacement. So distance and displacement comes into play when body is in motion. Means now we are discussing about the terminology, terms related to motion. In that, first we'll come across distance, displacement. Right? So commonly they look same. In our common words, we use same only. We never use the word displacement. But there is a difference is there. Right? Because distance is having only magnitude, no direction. That's why it is a scalar quantity. Whereas displacement is have both magnitude and direction, and it is a vector quantity. Okay. Distance is always positive. whereas displacement can be either positive or negative or even zero also. Right? Clear or not? Both are measured in meters only. Like that, there is a differences we discussed, and I explained you in details about the distance and displacement through the tabular form. You might have already written in your notebooks also. Then second set of words are speed and velocity. Speed and velocity. So these two are also derived from distance and displacement only, because speed is defined in terms of distance. Distance by time. Distance by time is called speed. Displacement by time is called velocity. That's all. So both are of, one is scalar quantity, other is a vector quantity. Speed of the positive is always positive or zero. Velocity can be either positive, negative, or zero also. Where there is a direction will come into play, there is a possibility of negative. As speed does not have any direction, it is always positive or can be zero. Right? So these are the two more terms. After distance displacement, we discussed about the speed and velocity. Then when you move forward, another important two terms, acceleration and retardation. You know, everybody commonly use the word, this is acceleration. That is increasing of speed. Time to time, if you increase the speed, it is called as acceleration. If you decrease the speed, it is called retardation or negative acceleration. Okay. So both acceleration or retardation are measured by meter per second square or centimeter per second square. Clear? So these are the total terms related to motion along with the time. Time is common everywhere, you can see. Right? Where the time is common only. Apart from this time, we have these many terms. Now, after knowing about each and every term regarding the motion, what we have done? We have derived the formulas related to the 6 to 7 terms. So we have seen the equation 1, the first equation of motion. So it is nothing but, you can see here, V is equal to U plus AT. You already written, right? So V is equal to U plus AT is the first equation of motion, where V is the final velocity, U is the initial velocity, A is the acceleration, and T is the time period. Time, right? Time taken. That is first equation of motion, what we have derived already, which is obtained from the definition of acceleration. Rate of change of velocity is called acceleration. A is equal to V minus U by T. From that, we will get the V is equal to U plus AT. So second equation of motion, you can see here. Right? Second equation of motion, you can see in the beginning. So S is equal to formula for the displacement, distance. S is equal to UT plus half or 1 by 2 AT square. You have noted in the notebook. So how this obtained? That also I explained you how this equation came. You can see in the next slide here. Right. So finally, after substituting the first equation, we can get the second equation as solved as S is equal to UT plus half AT square or 1 by 2 AT square. That is equation of motion number 2. Third one here. Equation number 3. V square is equal to U square plus 2AS. See, all the three equations contains the same terms which are we discussed when the body is in motion. So that is third equation. V square is equal to U square plus 2AS or V square minus U square is equal to 2AS. You can write, right? That is equation number 3, which we already derived in the last session. Right? So all the three equations are called equations of motion. Suppose one more is there. One more interesting formula you can note down now. So equation number 4. Sorry. So Sn is equal to un plus half an square. 1 by 2 an square. Right. Or you can write n also. S is equal to u into n minus 1 plus. That is only actually this one. So just a minute. So in a particular time, in a particular second, if you want to find out the distance covered in a particular time, for example, I tell the total I divide into 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 seconds. Right? So this is the first second, second second, third second, fourth second, and fifth second. Right? So suppose the total in 5 seconds body covers 10 meters. Body covers 10 meters in 5 seconds. What is the distance covered in 5th second? This is S5. In that case, you can use the particular second, you can use this formula. Or second second. Second second means what? One from first second to second. Third second is second to third. Third to fourth. In a particular time, suppose if you take your vehicles, when you are traveling by vehicle, we have the odometer and speedometers. Speedometer and odometer. Now, speedometer will be there. How much speed you are traveling. Anytime you can find out. Because when you are traveling, somebody called and asked how much speed you are going. By seeing the meter, you can find out how much speed you are. Either 40 kilometers per hour or 70 or 80. Like that, how much distance covered in a particular second can be calculated by the equation 4. Okay. Equation 4 of the motion. Right. So the final equation can be seen in the next page. You can find the, okay, not given here. So after solving the equation, we'll get the final equation here. After this, you can cancel out the minus plus will be un plus half an. Okay. So finally, you'll get this one. Just you in place of that un plus. So Sn is equal to u plus a into n minus half, you can write. Final formula. After all these calculations, some line is missing here. Okay. This is the final formula. Sn is equal to u plus a into n minus half. So n is nothing but a particular second. If your body starts with the initial velocity 5 meters per second and covers a distance of 100 meters in say 2 seconds. 5 meters per second is the speed. 100 meters is the distance covered. T is 2 seconds. What is the distance traveled in the by a body in a particular time, we ask. Okay. In such case, you can use u. Acceleration also you have to provide. For example, 2 meters per second square. So n we can take it as the number of seconds. Which second you want to calculate, you can calculate. N. U is the velocity. A is the acceleration. And n is the number. Which particular time you have to calculate. So this is the equation number 4. You can note down clearly equation number 4. The final equation Sn is equal to u plus a into n minus half. Right. So this is equation number 4. Right. Where n is the, that is we call nth second. Nth second means a particular second. Formula for nth second. Any particular second you can calculate, not overall seconds. In a particular time, that how much time they ask, that you can put in place of n. Directly you can get the distance covered in that particular second with a given acceleration. Okay, so this is called the 4th equation of motion. 4th equation of motion. So how many are there? There are totally 4 equations of motions. Number 1, V is equal to u plus at. right? Number 2, S is equal to ut plus 1 by 2 at square. Number 3, v square is equal to u square plus 2as. And number 4 is Sn is equal to u plus a into n minus 1 by 2. Okay. So these all 4 equations will come across when a body is undergoing in motion. When a body is in motion. Okay. Clear? So write down this 4th equation also. Under the this 4th equation derivation and all will come across in the higher classes. Okay. So all 4 equations you keep it at one side. Very, very important equations. We have to solve many problems by using them. So this is we completed some part, that is up to 2 synopsis of the chapter, right? Then before going for the next part, the next part already you have seen. We are going to, after getting the problems or solutions, that is after deriving the equations of motion, we have to go for the graphs, right? No, we have to go for one more topic is there, that is about acceleration due to gravity, followed by the few graphs we'll discuss in the next week classes. But before that, today we are going to have the worksheet. We'll go through the worksheet of different levels related to these 2 parts. The first part is about motion and rest and terms related to motion and rest. Second part is equations of motion, right? Based on that, there are some questions are given, multiple choice, choose the correct answers and various types. So we'll discuss from our material. So all of you, if you have materials with you, you can open or you can write in a notebook. So this is the level 1 sheet of this particular chapter. Just I am zooming this and we'll try to solve how many problems are possible. See, this is the motion level 1. You can see the page number also. Page number 40, sorry, not 40, 39. To open the page number 39 if you have the books. If not, no need, don't worry. So, page number 39. 39, we can find the right. You can find single correct answer type questions. So, what is the topic here? Topic is synopsis 1. Terms related to kinematics, like distance, displacement, speed, velocity, acceleration, deceleration. Based on these terms, questions are given here under level 1. There are some standard questions also you can find level 2, right? Okay. So first of all, you can see here what exactly you can find. If distance covered by a particle, see, first I will explain 5 questions. And after explanation, I give time for you to write the question answers. You write the question and write only answer, not all 4. Okay? In your notebook. If distance covered by a particle is 0, if distance covered by a particle is 0, what can you say about its displacement? If distance covered by a particle is 0, what can you say about its displacement? When distance covered is 0, displacement must be 0 only. When there is no distance covered, there is no chance of displacement. Okay? It must be 0. Question number 2. Which of the following is used to measure distance traveled by moving vehicle? Just now I told. Distance traveled, which one is found out? So, distance traveled is found by odometer. Speedometer will give the speed, how much speed you are going. You can see either you take 2-wheeler or 4-wheelers, you can find some meters. 1 meter will show how much speed you are traveling, 40, 50, 60, 100, like that to move. But second meter will show how much distance you are traveling, how many kilometers you are traveling. That one is called odometer, right? So odometer is a device used to measure the distance traveled by moving vehicle. So second answer is odometer. Velocity of a body is velocity. velocity of the body is scalar quantity, vector quantity, both 1 and 2. Right? So velocity can be either scalar or vector, depends on direction. If direction is there, it is a vector. If direction is not there, it is a scalar. So it comes under both 1 and 2. No, sorry. Velocity, na? It is only vector quantity. Just a minute. So velocity is a vector quantity. Velocity is vector quantity because it has both magnitude and direction. Speed. To use the word speed is only scalar. Okay. Fourth question. A body moving at uniform velocity 2 meter per second. Uniform velocity 2 meter per second will have uniform acceleration, non-uniform acceleration, zero acceleration, none of this. It is moving, see, uniform velocity. What remember uniform velocity? There is no acceleration. That is zero acceleration. Correct? Uniform velocity, body is moving to uniform velocity means there won't be any acceleration. If there is an increasing acceleration or decreasing velocity, then you can have acceleration. As it moves to uniform velocity, zero acceleration. So fourth answer is zero acceleration. Right? Clear? Second one. Fifth one, sorry. The SI unit of acceleration. SI unit is meter per second square. Centimeter per second square is a CGS. Okay. So meter per second square, rate of change of velocity. Change in velocity by time. So you know velocity is meter per second. Again, time is second. So what do you get? Meter by second square. Or you can write even meter second minus 2 also because square comes up. So answer is meter by second square. Right? So, okay, anyway, we can find this also. When a body is thrown upwards, the acceleration is negative only, going against the gravity. We'll learn more about the gravitational force. But when you are throwing the ball upwards, what happens? The velocity decreases. When you are throwing the ball upwards, the speed decreases and finally comes back to the ground. Why speed is decreasing? Because it is a negative acceleration. Okay. Seventh one. First 7 I can complete, right? Seventh one. So if a velocity of the object changes by an unequal amount of equal intervals, unequal amount in equal interval of times. So that is non-uniform. Equal distance, equal interval, uniform. Equal distance, unequal interval, or equal in time, unequal distance also comes under non-uniform acceleration. Okay. So these are the 7 questions. First you complete the level 1 questions. After that, we'll move to the level 2. You write down all these questions. So what I want to tell you is write questions and write only answer, not all 4 options. Teachers, make sure that students wrote questions in the notebook. First, write all 7 questions and answers in notebook. I'll give some time for you. Okay? Open your notebook. Write the heading as worksheet level 1 related terms related to kinematics. So question number 1, in brackets write answer. Don't write all the options. Question number 2, answer. Question number 3, answer. Question number 4, answer. 5, 6, 7. 7 questions are given under level 1 on topic of terms related to kinematics. If you complete this, we'll go for level 1 questions on equations of motion. Make it fast. Just write the question in bracket, write the answer. And try to understand the concept. Jogipet, Banur, Dulapalli, Indra Sen, Karmanghat, Kishanbagh, Ramnagar, Jahanuma, and the ECL branches. Good to see you all. Hope you are writing fast. Unequal amount in equal interval. Last one. Non-uniform acceleration. So these questions are related to terms related to kinematics: distance, displacement, velocity, speed, acceleration, deceleration. We have seen the differences between them in the table column. Right. So just to move to the next part. Next questions based on kinematic equations. That is, I told 4 equations. Equations of motion. The questions are based on that. Right? See now. So what is the question number 8? Question number 8. When a body is projected upwards. When a body is projected upwards means thrown upwards. The acceleration acting on is negative. Correct or not? When a body is thrown upward, what happens? Speed decreases. Why decreasing? Because acceleration is negative. The decreasing acceleration is nothing but negative acceleration, retardation. Which one is the example for uniform motion? Which one is the example? Uniform motion means covering equal distance, equal time. A freely falling stone? No. A stone projected vertically upwards? No. A bicycle driven on crowded road? There won't be any uniform. So, Earth revolving around its axis is because Earth revolves with same speed, constant speed. A body moving with a constant speed is called uniform motion. Earth always takes same time to complete one revolution around the sun, maybe 365 days or whatever, 24 hours, right? So example for uniform motion is Earth turning around its axis. Okay. Next one. When distance traveled by a body is directly proportional to square of the time taken. S is directly proportional to T square. Is asking. Okay. The motion of the body is depends on time is what is mean? It is not uniform. It is uniformly accelerated. The body is accelerating uniformly, means changing the speed with uniform velocity. Then we can call it as body is in uniform accelerated motion. Means it is increasing the velocity at constant speed. Okay. These are the questions given for the topic kinematic equations. Write down 3 questions. Next we'll go for level 2. After reading these 3, we'll go for the level 2. This is the question given. Okay. Because next topic is not covered yet. Acceleration due to gravity. So by now we are completed the level 1, right? So level 1, 10 questions are there totally. One is based on the terms, second is based on the kinematic equations. So make it fast. Write these 3 questions. We'll go to level 2 of these 2 topics, these 2 synopses. Speed. Make it fast. Yes, Indra, same. Why you are talking? Mute yourself. Okay. Hope you are done. Right. So I'm moving to the next part. So this part we are not covered yet. Now this is level 2. What is this? Level 2 means little standard questions based on same topic. Terms related to kinematics. So we'll solve 1 or 2 before the completion of time, right? So what is the first question you can see here? A car travels a speed of, speed is given. Suppose speed. First speed how much? 50 kilometer per hour. Right? In first hour. 100 kilometer per hour in second hour. Speed 1, speed 2 will say. Speed 2. That is 100 kilometer per hour. What is asking? What is the total distance covered by a car in 2 hours? Same. First hour 50, second hour 100. 50 plus 100 you can do, because 50 in 1 hour it travels 50 into 1. In second hour and again 100 into 1. Speed into time. Distance is equal to speed into time. Right? Speed is equal to distance by time. Na? So what is speed here? Speed is first case 50. Time is 1 hour. Second case, time is 100. Time is 1 hour only. Second hour means, so total 150 kilometer. Answer is 3. In first hour, it covers 50 kilometer per hour. Right. That is, distance is equal to speed into time or velocity into time. Speed is 50 kilometer first case. Time is 1 hour. Second case also 1 hour, but speed is 100. So distance for first case is 50 kilometers. Second case is 100 kilometers. Total is 50 plus 100 gives 150 kilometers. So answer is 150 kilometer. Okay. Next you can see Telangana Express moves at a speed of 110 kilometer per hour. How long it will take to cover a distance of 50 kilometer? Very interesting, you can see. Just a minute. So what he's saying here, the speed is given. Speed is equal to 110 kilometer per hour. And what is given here? Distance. Distance is equal to 15 kilometer. And he's asking how long is time? How much time it will take? How long means time? Take to cover the 15 kilometers. So, you know, distance is equal to, speed is equal to distance by time. So time is equal to distance by speed, the formula for time. Right. So what is the distance here? 15. 15 by speed is 110. Right. So this will come in hours. We'll get in hours. 15 by 110 hours. Okay, that is nothing but approximately 0.1. Because if you take 110 by 15, you can keep the 0 point here and 0. 150 will come, 110 ones are 110, 40 is there, around 3. Approximate hours this is. Hours you have to convert into seconds. So 1 hour, how many? Oh, sorry, minutes is given. Answer is given in minutes. So 1 hour is equal to how many minutes? 60 minutes. So you can do into 60. So you'll get 8.1 minutes. Right, you can find the solution in the material we given. Okay, there you can find the solution for this. Simple. Just you have to, we'll get the answer in hours. You have to convert that into minutes. 0.136 will get into 60. Why you are doing 60? We are converting hours into minutes. So you get 8.1 minutes. Right? So remaining problems you try yourself before the exam, or when we are meeting next class, we'll solve as the time is running. So you copy the two problems, these two problems. So solutions you can check in your material. Already we give the solutions for you. These problems are given solution level 2, level 3. Okay. So first one is 150 and second one is 8.1. So note on those two questions. Remaining questions will solve in the next class. Right? Right, students? So you can check from your materials. That's all for today. So practice well for the worksheets what we have done so far on two topics only. Terms related to kinematics and equations of motion or equations of kinematics. Work on that. Complete remaining questions of level 2. If try to possible, level 3, level 4 also there, I think. Okay. So thank you very much all of you. Have a wonderful day. Have a wonderful weekend. Thank you.